In this video, we will discuss about minimum total distance traveled. There are some robots and factories on the x-axis. You are given an integer array robot where robot of I is the position of ith robot. You are also given a 2D integer array factory where factory of j equals to position comma limit indicates that position is the position of jth factory and that the jth factory can repair at most limit robots. At any moment, you can set the initial direction of moving for some robot. Your target is to minimize the total distance traveled by all the robots. Return the minimum total distance traveled by all the robots. So what they are saying is that in the input, you are given two arrays, which is robots and factories. Robots is denoting the position of the robots which are present on this number line, and factory is a 2D integer array where the first element denotes the position of that factory on the number line and the second element denotes the limit of this factory, meaning how many robots that particular factory can repair. So what they are saying is there are three robots at these positions. So it is 0th position, 4 and 6. So at these three positions our robots are present, and then the factories are present at 2 and 6, right? So at 2 we have a factory and at 6 we have a factory, and the limit of both of these is 2, right? Meaning they can repair at most two robots. Now what you need to do is these robots, they can move in any direction, left or right. They all move at the same speed and they never collide with each other. Initially all of these robots are broken and they can be repaired with the help of a factory, right? So what we need to do is we need to move these robots in any direction so that they can be repaired by a factory, and then whatever distance these particular robots have traveled from their initial position till the factory at which they are repaired, that distance we need to calculate for all the robots, and whatever is that distance we need to minimize it and return it as our answer, right? So if you see here, we have three robots at 0, 4 and 6, and we have two factories at 2 and 6, and their limits are 2. Then that means this robot can be repaired by this factory and this robot can also be repaired by this factory because the limit is 2. And then this robot can be repaired by this factory, right? Then what is the distance that they have traveled? So for this robot to be repaired by this factory, it will have to go 2 units, right? 2 minus 0 will be 2. Now for this particular robot, this can either be repaired by this factory or this factory, right? In both factories, it will have to travel 2 units of distance, right? So we'll consider it 2. Then for this particular robot, now you see it is already present at a factory. It can be repaired by it. So the distance traveled by this robot will be 0, right? So the total distance traveled by all the robots will be 4, and this will be your answer because this is the minimum total distance that you can achieve, right? So now how are we going to solve this? So if you see here, if let's suppose this is our number line, right? And let's suppose I have a robot here, one robot here and one robot here, right? And then I have some factory here, some factory here, some factory here, and then some factory here, right? So in this case, if you will see that if I want to fix this particular robot, then since I want to minimize my total distance traveled, I will try to repair this robot with the nearest factory to it, right? So nearest factory is this and this. So I will try to repair this robot with these two factories. But this also depends upon some conditions, that is this factory available or not, because it has some limit. For example, let's suppose the limit of this factory was 1 and this factory has already repaired this robot. Then in that case, you cannot get this robot repaired with this factory because its limit has been reached, right? So one thing that is for sure is that we need to get our robot repaired with the nearest factory possible so that we can minimize the total distance traveled, right? We will not repair this robot with this particular factory or this particular factory, right? Because those are farther away from this robot, right? So since we want to assign a robot or get a robot repaired by the nearest factory, what are we going to do is, so in the input we are given robots like this and factories like this. So for simplicity, we will flatten this 2D array into 1D array. So that is simple. What we'll do is that first factory is at position 2 and its limit is 2. So we will keep its position 2 times, which is 2, 2. Then this factory is present at position 6 and its limit is 2. So we will keep 6, 6 twice here. Right. Now, if you see, we have the position of all the robots and we have the position of all the factories, right? Now, it will simplify our logic a little bit. Now, what we can do is we can sort these two. If we will sort these two in increasing order, then what will happen? It will help us optimally assign the factory to the robots, right? Because we want to assign the nearest factory to a robot, right? So now when you will sort them, then what will happen? Now this is already sorted and this is also already sorted, right? So now what will happen is that for this robot 0, it can get repaired by this factory 2. So 0 will be repaired by factory 2, right? Then in that case, for the remaining robots, which is 4 and 6, you are left with the factory at 2, 6 and 6, right? So then for this 4, you can get it repaired with either the factory at 2 or the factory at 6, right? And then if instead of repairing this 0th robot with the factory at 2, we can repair it with this 2, right? So in that case, what will happen? That 0 will get repaired at this factory 2, and then for 4 and 6, you will be left with the factory at 6 and 6, right? And then in that case, you can get repaired this 4 with the factory at 6 and this 6 with the factory at this 6, right? So basically, you are trying all the different combinations, right? So now whenever you are pairing this 0 with this 2 and then this 4 with this 2 or with this 6, at every moment you can find out the distance, right? You can find out what is the distance between this particular factory and the robot by doing its difference, right? And you are trying every possible combination also. So if you will do the sum of all these distances, you will get the total distance traveled by all the robots in one particular combination, right? And you are trying all the different combinations. So out of these, whichever is the minimum, that distance you can take, and that will be your answer, right? So basically, we are trying all the combinations of what? Robots and the factory. And since we have sorted these, right? If you see in this particular case, when we repaired robot 0 with the factory at 2, which is this one, then for these two robots, we consider the factories at 6 and 6 only. We didn't consider the factory at this particular 2. Why? Because since our arrays are already sorted, if we will use this factory at 2 for these two robots, then it will only increase our distance, right? And we want to minimize it. We do not want to maximize it, right? That is why we have left this 2 and we are only considering the remaining factories for the remaining robots, right? So it is a simple approach, simple brute force that we are doing, that we are checking all the different combinations and then we are finding out in whichever combination will be the minimum distance, right? So what you will do is you will perform recursion, right, for finding out all the combinations. So at every recursion point, you will have two things. What all two things you will have? You will have the current robot, right, and you will have your current factory, right? These two things you will have. Now, for these two, you are having two choices. What are the two choices? That either you repair this current robot with the current factory, or you skip this current factory and you move to the next factory, right? So these are the two possible choices. So what we'll do inside our function is that first is that we are repairing it with the current factory. So in that case, what will happen is, so since we are repairing this current robot with this current factory, we need to find out the distance between these two, right? So what we'll do is, we'll do absolute of whatever is the position of robot. So it will be given by robots of current robot minus the position of the factory, which will be, let's suppose the array is factories. So in factories, whatever is the position of current factory, right? So this will give you the distance that this particular robot has to travel to get it repaired with this factory, right? And in this, you will add whatever is the distance you are getting for the next remaining robots. So here you will call your recursive function again. So let's suppose that is helper. So here you will call helper. Now in this, since we have repaired this current robot with the current factory, we will move to the next robot and the next factory, right? So in that case, you will pass current robot plus 1 and current factory plus 1, right? So this is the case where we repaired the robot. Now the next case is that we are not repairing this robot with this factory, we are skipping it, right? So in that case, what you will do? So you'll do skip equals to, now since we are not repairing it, then we do not have to find out the distance between the robot and the factory, right? So we will simply call the recursive function again. Now inside this, we are not repairing robot, so current robot remains as is, but current factory becomes plus 1 because we are moving on to the next factory now, right? So these are the two recursive calls that we'll make. So this will give us two distances. Now since our target is to find out the minimum distance, so here we will return the minimum of these two. So return minimum of repair, comma, skip, right? So now what will be your base conditions for this recursion? So first is that if let's suppose the current robot becomes equals to the size of the robots. So that is robots dot size. What does it mean? That we have exhausted all the robots or we have repaired all the robots, right? So in that case, you will return 0, right? And the other cases where the current factory becomes equals to factories dot size. So in this case means that we have exhausted all the factories and we have not repaired the robots, all the robots. So in this case we can return a big number, any big number. So that will not be considered here because we are taking minimum here, right? So let's suppose you returned int max here. Any number, any big number we can return. So now this is our recursive function which will give us the minimum total distance traveled by all the robots to get repaired by the given factories, right? Now since this is going to take a lot of time complexity wise, so you can memorize it. You can create a dp vector, so that dp vector will be a 2D dp vector. Now why this is going to be a 2D dp? Because see, there are two things which are changing, which is current robot and current factory. So both the things need to be tracked. So that's why we are creating a 2D DP, where this will denote the robots and this will denote the factories. Before calling these recursions, you can check that if DP of current robot, current factory is not equals to -1, then you can simply return that value. Otherwise, you can call these recursions. And while here you are returning the minimum of repair and skip, here also you can assign it in the DP. So you can say DP of current robot, comma, current factory equals to minimum of repair, comma, skip. And this is how you can memorize your recursive function. So let's code it out now. So first of all, we need to sort robot and factories. So we'll do sort robot dot begin, comma, robot dot end. Then we need to sort factory. So we'll do sort factory dot begin, comma, factory dot end, right? Now we need to flatten this factory vector into a linear array, right? So for that, we will create another vector. Let's suppose its name is factory positions. Now in this, we need to update all the values. So we will loop inside factory. So it will give you, let's suppose F. So auto F in factory. And in this, we'll run another for loop. So this will run from I equals to 0, I less than f of 1. Now why f of 1? Because the second element in this is telling you the limit of this particular factory. That's why. And then we'll do I plus plus. And then inside this, in the factory positions, we will push back f of 0. Because f of 0 is denoting the position of the factory. Right? And then we need to create our dp vector. So it will be a 2D dp. It will be of type long long because we need to return long long. So let's name it dp. Now what will be its size? Its size will be robot.size into factory position.size. Right? So we'll do robot dot size, comma, vector long long, and inside this we'll do factory position dot size, comma, -1. Initially all the values will be -1. Then we need to create our recursive function. So this recursive function will give us a long long. So let's name it minimum distance. Now what all it will receive? So first it will receive the current robot, then it will receive the current factory, and then we need the robots vector. So it will be vector int robots, then factories, so vector int factories, and then we need the dp vector, right? So it will be dp, right? So now inside it, what are all the base cases? So if the current robot becomes equals to robots dot size, right? In that case, you will return 0. Then if the current factory becomes equals to factories dot size, then we need to return some big number, right? So we'll return this, right? Then we need to check that if for this particular robot and factory, the value is already present in the DP or not. So we'll do that if DP of current robot, current factory is not equals to -1, then in that case, return DP of current robot, current factory, right? And if it is not present, the value is -1, then we'll call our recursion. So it will be first case, that is long long assign equals to. Now here we are repairing the robot. So we will first find out the distance between the robot and the factory. So it will be robots of current robot minus factories of current factory, right? And then inside this, we'll call the recursive function for next robot and next factory, right? So we'll do current robot plus 1 and then current factory plus 1, and then rest of the things we can pass as is, which is robots, factories and DP, right? Then the next case is where we are skipping this current factory. So there it will be long long skip equals to minimum distance, and in this the current robot will remain the same, but the current factory will become +1 now, right? And the other things can be passed as is. So robots, factories and DP, right? And then we need to return the minimum of these two and assign in our DP vector also, right? So we'll do DP of current robot, current factory equals to minimum of assign, comma, skip, right? Now we can simply call this recursive function here and we can return the minimum distance. So we'll do return minimum distance. Now inside this, the current robot will initially be 0, current factory will initially be 0, and then we need to pass the robot vector, then the factory positions, and then the DP vector, right? So let's run this now. So our test cases are accepted. Now let's submit this. So it got accepted. Thank you so much for watching. Please subscribe our channel.